Let us study today applications of zero field splitting to odd number of unpaired electrons. How it is applied in predicting the number of EPR lines. For example, cobalt 2 plus and chromium 3 plus systems. Let us consider transition metal ions with the odd number of unpaired electrons. For example, chromium 3 plus with the D3 electronic configuration, there are 3 unpaired electrons. Similarly, cobalt 2 plus with the D7 electronic configuration, there are 3 unpaired electrons. Therefore, S equal to 1 by 2. The total spin is 1 by 2 plus 1 by 2 plus 1 by 2 equal to 3 by 2. The spin multiplicity is calculated using this formula 2s plus 1. Therefore, this is a quartet state. This is a quartet state. For S greater than 1 by 2, for example, S equal to 3 by 2, there are 3 unpaired electrons, 5 unpaired electrons, 7 unpaired electrons, etc. Such systems exhibit zero field splitting and also Cramer's degeneracy for odd number of electrons. We have already seen. For transition metal ions, that spin orbit coupling is large. We have already studied in LS coupling scheme in the previous class. Please watch the video lesson. Chromium 3 plus D is greater than 0, whereas for cobalt 3 plus D is very much greater than 0. Let us consider organic molecules or transition metal ions with the total spin 3 by 2. The spin degeneracies are ms equal to the spin orientation quantum numbers are plus or minus 1 by 2 plus or minus 3 by 2. There are 2 possible cases. One is D greater than 0. Another is D is very much greater than 0. D greater than 0. Okay. So, in the presence of zero field splitting, it splits into 2 levels. Okay. In the presence of Zeeman splitting, in the presence of magnetic field, it splits into 4 levels with the minus 3 by 2 as the ground state for EPR. For Mi in NMR, plus 3 by 2 is the ground state. It will be opposite, plus 3 by 2 plus 1 by 2. Okay. In this case, as you see, D is very much greater than, this is the microwave frequency transition. This is the microwave frequency h nu. Here, h nu is greater than, you see, h nu is greater than D. Here, the microwave frequency, you see, the EPR transition microwave frequency is, D is greater than h nu. Okay. So, there are 2 cases I have shown here. D greater than 0 is observed for chromium 3 plus. This splitting is used to explain cobalt 2 plus EPR spectra. Let us consider case 1 where D greater than 0 in the presence of zero field splitting. For example, in the presence of zero field splitting, it splits into 2 levels. The ground state for species with the odd number of unpaired electrons, the ground state is always degenerate, that is doublet. The ground state is doubly degenerate. The ground state is doubly degenerate. That is called Cramer's degeneracy. This is called Cramer's degeneracy. Cramer's degeneracy leaves the ground state doublet. Okay. Further, in the presence of magnetic field, in the presence of zero field splitting, and further in the present, it splits into 4 levels, spin levels. Okay. So, there are 3 possible transitions using the EPR selection rule. Delta m is equal to plus or minus 1. Okay. This the transition from minus 3 by 2 minus 1 by 2. The transition from minus 1 by 2 to plus 1 by 2. are allowed using the EPR selection rule, delta ms equal to plus or minus 1. For this is the splitting diagram for chromium 3 plus D3, where the spin orbit coupling is large. The second case where D is very much, the zero field splitting is very much greater than h nu, the microwave frequency, or D is very much greater than 0. It is usually observed in the case of cobalt 2 plus D7 electronic configuration. In the presence of large zero field splitting, it splits into 2 levels, and further in the presence of Zeeman splitting, it further splits into 4 levels. It splits into 4 levels. Okay. So using the EPR selection rule, delta ms equal to plus or minus 1, only one transition is observed. Using the selection rule, only one EPR signal is observed. Since the zero field splitting D is very very large, the lowest lying doublet is far separated. The difference between the lower lying doublet and higher lying doublet are large. The difference in energy is large, or the lowest doublet is far away from the separated from the higher doublet. So this minus 1 by 2 plus 1 by 2 is independent, minus 3 by 2 plus 3 by 2 is independent. Therefore, the effective spin, you see, in this case, the effective spin is S prime equal to 1 by 2 for cobalt 3 plus, although S equal to 3 by 2, the effective spin, because of large zero field splitting, the effective spin is 1 by 2. Okay. Therefore, there is only one transition. This is again a forbidden transition, because 3 by 2 minus 6 by 2. Therefore, 6 by 2 means 3. It is it is forbidden transition. According to EPR selection rule, this is forbidden transition. The ground state spin levels are only populated. Therefore, only one EPR signal is observed. Thank you for watching.